I am Stephen Strange, master of the mystic arts, but today I have set aside sorcery to guide you through the vast history of the cosmos itself. In the absolute beginning, everything that ever was or will be was compressed into a singularity, a point in space where mass is crushed to infinite density. Then the Big Bang erupted, and time began its relentless march outward. At that exact instant, before the universe stretched into the expanse we recognize, many versions of myself slipped through the veils between realities. Across the multiverse, each Strange silently witnessed the birth of this specific reality, calculating the forces at play. That microscopic, fiery chaos lasted only fractions of a second. Yet that brief window of extreme heat and compression established all the physical laws that govern space and time today. This line graph tracks the density of the newborn universe over time. In less than a heartbeat after the initial expansion, the cosmos was denser than the core of a neutron star. Reality was hotter and tighter than any spell I could conjure. A few fleeting seconds later, the universe cooled and expanded enough that its density dropped to rival that of a white dwarf star. Even at just 1.8 seconds old, space carried the crushing weight of stellar corpses. At the 3-minute mark, nucleosynthesis began. Nucleosynthesis is the cosmic alchemy where protons and neutrons first fused together. Hydrogen and helium were forged in a primordial fire, with a density of roughly 100,000 kilograms per cubic meter. The drop continued rapidly. Only 12 minutes later, the infant cosmos passed through the density of Earth itself. By 21 minutes, the universe resembled the density of Sagittarius A star, the monstrous black hole that lurks at the heart of our own galaxy. 62 days into its existence, the overall density of the universe matched that of a black hole carrying the entire mass of the Milky Way. For the next 13.8 billion years, that density continued to plummet. Today, it rests at a whisper, 10 to the negative 26 kilograms per cubic meter. The universe spent its entire lifespan escaping that initial infinite compression. It stretched its fabric to near emptiness, creating the necessary stable canvas for stars to ignite, planets to form, and minds to eventually look up and ask questions. Density continues to shape the modern cosmos. As the universe expanded, it left behind localized pockets of infinite hunger, black holes. To demonstrate how these objects warp space, I must step through the looking glass. Here, in the mirror dimension, we can safely conduct a thought experiment about extreme gravity without tearing apart our actual reality. This animated diagram breaks down the Schwarzschild radius. I scoured the multiverse for the math that governs abyssal giants, and this equation appeared across infinite worlds. It calculates the exact boundary of a black hole using only 3 variables: mass, the gravitational constant, and the speed of light. The rule is precise. Take any physical object and compress it tightly enough, and it will reach a threshold where its gravity prevents absolutely anything, even light, from escaping. That boundary is called an event horizon. Because the speed of light and gravity are constant, the size of a black hole is dictated entirely by its mass. Abstract mathematics creates literal, inescapable borders in physical space. Let me show you how those borders materialize. If you were to compress the entire mass of the Earth down to its Schwarzschild radius, it would form a black hole no larger than 1.8 centimeters. It would easily fit in the palm of your hand. Now, scale that math upward. Imagine if our local star surrendered to the fate of a black hole. Compressed to its event horizon, the Sun becomes a sphere of utter darkness just 5.9 kilometers across. Hovering here in the mirror dimension, you can see it spans roughly the width of Manhattan itself. This top-down view of our inner solar system shows the scale of Sagittarius A star, the black hole at the center of our galaxy. Its event horizon spans 24 million kilometers. That is wide enough to completely engulf the orbit of Mercury. We can push the thought experiment further. If you took the entire mass of the Milky Way galaxy and collapsed it, the resulting horizon would measure nearly 9 trillion kilometers, almost a full light year across. And at the absolute limit of the mathematics, If the mass of the entire observable universe were compressed, its event horizon would span 31 billion light-years. Whether an object begins as a marble or a galaxy, extreme mass invariably warps space into these terrifying, inescapable horizons. That final calculation leaves a shadow hanging over our understanding of space. If the mathematical radius of the observable universe is 31 billion light-years, do we live inside a universe-sized black hole right now? In a purely mathematical sense, we dwell within that exact Schwarzschild radius. However, the center mass of our universe is distributed differently. It lacks the density required to drag itself backward into a singularity. A black hole simply crushes and traps. Our universe stretches, cools, and breathes. It expands continuously, pushing matter apart rather than pulling it into a single point of oblivion. It is a cradle, not a prison. Testing these limits, from a marble-sized Earth to a 31 billion light-year horizon, shows us exactly how mass bends our reality, and it reminds us that even a sorcerer supreme remains an eternal student of its unfolding mysteries.